is NASA known for? What would most people say? The answer may not surprise you. Most would undoubtedly speak about NASA's past and present space flights and recent developments of new technologies and breakthroughs in science. While NASA does focus much of its efforts on projects that are outside of our home planet, much of NASA's research and development is performed closer to home. The first A in NASA stands for aeronautics, and that focus on aeronautics is just as strong today as it was in the past. Looking back to the early history of NASA and its predecessor agency, the NACA, much of the pioneering work in aeronautics was carried out by experimental aircraft that later became known as X-planes. X-planes are a series of United States aircraft and rockets used to test and evaluate new technologies and aerodynamic concepts. The X designator denotes the unique experimental research mission. For decades, these unique aircraft flew around California's high desert, pushing the envelope of flight mechanics and providing a solid foundation for our understanding of aeronautic principles to help solve major aviation challenges. X-planes and other prototype air vehicles hold a special place. They're a glimpse into the future of what supersonic aircraft and spacecraft may become. Over the last 7 decades, they've been a proving ground for developments, including delta wings, tailless aircraft, and supersonic flight. Vehicles that fly at supersonic speeds are flying faster than the speed of sound. The speed of sound is about 760 miles per hour at sea level. These speeds are referred to by Mach numbers. The Mach number is the ratio of the speed of the aircraft to the speed of sound at altitude. Flight that is faster than Mach 1 is supersonic. Supersonic includes speeds up to 5 times faster than the speed of sound, or Mach 5. From the first flight of the X-1 in 1947, all the way through X-plane flights in the early 80s, NASA and the military have built many X-planes that help challenge and change our understanding of aeronautics. Eventually, the emergence of advanced computing, coupled with constrained budgets, helped slow the development of full-scale X-planes and led more to the use of smaller, uncrewed aircraft for testing. But even with computer simulations and small unmanned aircraft proving to be powerful tools in the development of new aircraft, researchers understand that there is still a need for the development of full-scale, piloted X-planes to help close gaps in our understanding of aeronautic principles. The Lockheed Martin Skunk Works team, contracted by NASA, has built a new, full-scale X-plane called the X-59.